This is Jun2006 question 4. Distinguish between kinetic energy and gravitational potential energy. So kinetic energy is energy a body has due to its motion. I'm not writing the whole thing in, but you can, due to its motion. So energy a body has due to its motion, and then this is energy a body has due to its height above the Earth's surface. Right, part B, a particle possesses energy in two forms only, kinetic and gravitational potential. It has a total energy of 3 and is initially at rest. Its potential energy changes, causing a corresponding change in its kinetic energy. No external work is done on or by the system. On the axis, draw a graph of kinetic energy versus potential energy. Now, we know that the total is always 3. So as a kinetic, if you must always have your addition of potential and kinetic adding up to give you 3. So 3 plus 0, so if you had no potential, you'd have 3 kinetic. If you had 1 potential energy, 1 joule of potential energy, then you must have got 2 joules of kinetic. If you have 2 joules of potential energy, then 2 and 1 makes 3. And if you've got 3 joules of potential, then you've got no kinetic. And so your graph is just a straight line, which goes down like that. Explain how your graph illustrates the principle of conservation of energy. And it explains it, or it shows that, because every time you add up the total amount of kinetic and the total amount of potential, you always end up with an answer of 3. So it's always constant, so no energy is being lost. So no energy created or destroyed. And I'm going to write in the total GPE plus the total kinetic energy always equals 3 joules. And that proves that none has been created or destroyed. Part C. An ASphysics student plans to enter for the high jump event at the school sports. She estimates that if she is to have a chance of winning, she will have to raise her centre of mass by 1.6 metres to clear the bar. She will also have to move her centre of mass horizontally at a speed of 0.8 metres per second in order to roll over the bar at the top of her jump. So she's got 2 types of energy she has to have. She must be able to raise her height by 1.6 metres, and she must also be moving at a speed of 0.8. So all you have to do is calculate the total, and that's the kinetic plus the potential she needs. And so that's half by 75 by 0.8 is the speed squared, and then plus we'll just put that in a bracket, plus m, which is 75 times 9.81 times 1.6. And that answer comes out to be 1,201.2 joules. We'll just leave it 1201. The student assumes that the energy can be supplied entirely from the kinetic energy she will have at the end of her run-up. Estimate the minimum speed she will require at the end of the run-up. Now, that is just you working out how much kinetic energy, how much velocity she should have from the kinetic energy. So how much kinetic energy has she? She must have 1,201 joules of kinetic energy in total. And that's equal to half times mass times this velocity, the minimum speed that she requires at the end. And so whenever you rearrange that and square root it, it comes out to be 5.66 or 5.7 metres seconds to the -1.